This conference will now be recorded.
So, till now we were discussing all about all the nodes and what are the functionalities of the basics. So, in today's discussion, I'll discuss more. Okay, most of our concentration will be towards the mobile and the base station. So, presuming this is my mobile, so in the last class, okay, I'll just give a small briefing on the last class and then we will go ahead with the other part. So, what I want to say is basically. Okay. So basically what we have is, so we have a mobile, we have the base station, okay, and we have an EPC. So here inside the EPC, we have MME, Mobility Management Entity, we have Serving Gateway, we have Gateway, and we have PDN, and we have PCRF. So this is how the whole system is there, right? So we know the functionalities of each and every node now. Okay. So we know what is eNode be doing. Okay. So we know what is MME doing. We know what is HSS doing, and we know what is S gateway doing. We know what is PCRF doing, P gateway doing, and PDN doing. So out of all these things, okay. So the basic thing is when you're working in any company, okay, when you're working in any company, okay, so basically the profiles are either you will be working at UE side, mobile side, or you will be working on the network side, that is on the EOB side, okay, or you will be working on EPC side, okay, you will be working on EPC side. So there are three different types of engineers which are present. So there are guys who are working on UE side, there are guys who are working on the ENODB side, and the guys working on the EPC side. Okay. So now what happens is basically, for example, you are a mobile engineer. Means if you are working towards UE side, okay. So you will only get the signal and you will receive it and you will send it. That's it. You know only this part. You know. Okay, so when you work on the EPC side, okay, so basically you will know only what has been received by the eNodeB, okay, and what you are sending. So, but when you're working on the eNodeB side, okay, you should know how the eNode is performing towards UE and how it is performing towards EPC, both the sides. Okay, so the most critical job or the most challenging job is towards eNodeB side. This is the most challenge. Okay, so the challenge is at the network side. Okay, so UE side is also good. Okay, we cannot say it is not good, but it is actually easy to work in the UE side. Okay, it is very easy to work in the EPC side, but the biggest challenge comes is, okay, if you feel like challenging, okay, if you want to learn things in the LTE network, you want more challenges in the LTE network, try to get in a job in the ERB side. No, I want an easier job, then you can prefer to work towards UE side. Okay, so that depends upon your decision. Okay, so but the thing is, what I can say is, so whatever the functionalities, whatever eNodeB has towards UE side, same functionalities UE also has towards eNodeB side. Okay, so the functionalities are like they are mirrors. Okay, so that means, for example, we have a physical layer here doing the same work, the physical layer here also doing the same work. Okay, so we are having other layers, okay, doing the same work, okay, here also doing the same work. That means UE and the base station are doing the same work. So, but only the thing is, eNode B or the base station will do the scheduling for multiple users, but UE is a single entity. Okay, it is only one single entity. So, but we will have much more clear discussion. Okay, so first of all, we will see this challenging part. Okay, so first we will see this challenging part, then I will try to concentrate how eNodeB and EPC are communicating with each other. So in today's discussion, I will start with how mobile and base station are talking to each other and what are the challenges are there between. Means this comes for both. So how UE is responding to E node B and how E node B is responding to the UE. Okay, and more importantly, all 90% of the stack engineers work in this interface. If you're working in the UE side or the base station side, that is in the air interface. Okay, so anyways, so what I can say is now in today's discussion we're going to concentrate towards in today's discussion we're going to concentrate towards base station, E node B2, V. Okay, so something between the mobile station to or the base station to the UV side. So basically what we have is okay. So basically what we have is so this is the mobile and this is the base station. So basically what we have is between mobile and the E node B we have some challenges in the air interface. Okay, I'll first list out those challenges. Okay, so the first challenge is bands. The second challenge is bandwidth. The third challenge is OFDMA. The fourth challenge is SEFDMA. The fifth part is uh, body ration. The sixth part is frames. The seventh part is MIMO. Okay. The seventh part is MIMO. So these are the challenges what UE and E node B has it. So all these challenges, what between E node B and UE comes at unit that is called as RF. Which unit? They comes under RF unit. So now, okay. So now the thing is you have to understand what all these terminologies are. So for understanding these terminologies, I'll try to draw the exact structure of E node B and UE. Okay, how exactly UE and E node B is exactly looking. Okay, so for example, if I take my mobile, okay, so for example, if I take my mobile UE, this is my mobile. So when I take my mobile station, okay, so when I take my mobile station, this mobile, this mobile station, okay, so basically contains, so obviously it contains three units. Okay, this is my mobile. This contains processor. Sorry, I can say memory. Memory means RAM and ROM comes under it. Second part is it contains a processor. Okay, and the third part is it contains an RF unit. This RF unit is connected with the antenna. So this is the mobile. This is your mobile. Mobile contains a memory, a processor, and an RF unit. Okay, in the same way, your base station. Okay, so your base station also. So presuming this is your E node B, so that is your base station. So this base station also contains a memory, so which contains a RAM and ROM, a processor, and an RF unit. Internet contains antennas. Okay, so this is your E node B and this is your UE. So both are same, right? There's no difference. So UE and E node B. So basically what happens is, if you, okay, the basic thing is, we have in the memory, okay, there are some divisions in the memory. Okay, so in this memory we will put your protocol stack, means protocol software, and your Android software. Your protocol stack and Android software is present inside this memory. So here in this memory only protocol stack, means that is the software is present. Now, presuming if you say that you're working in the base station side, you should know what is the memory size of the base station. Okay, if you say that I'm working on the base station, you should know that yes, this is what is the memory size of your ENODB. I'll tell you. And you should know which processors are being used in the ENODB and which processors are being used in the UD side. Okay, and this is where it is present, and processors will pick the software and process it. Get processed. Okay, whereas RF unit will take this command from the processor and will process the RF signals. Will process the RF. So this is how your RF signal is generated, right? Right. So same process happens in the eNode B also. In the eNode B also you have memory, processor, and okay. So now, okay. So when you want to buy a computer, okay. So when you go to the shop and say, give me a computer with RAM, ROM, processor, and all, okay, what he will say? He will first laugh at you, isn't it? So when you say, give me a system, give me a system with the RAM, ROM, that is memory and processor, he will simply first tell me the configuration. Okay, you tell me what is the RAM size you want, what is the ROM size you want, what is the processor you want. Again, he will ask you, you want AMD processor or Intel processor? Isn't it company's processor? Here also it is the same in the market. So if you are working on the UE side, you should be knowing, okay, what is the memory of RAM and ROM which is present inside your UE. Okay, and what is the processor? Okay, so when I ask you the processor, okay, i7, i5, okay, so here also we have quad core processors, 4 core processors, processors which work on ARM, processors which work on DSP. Okay, a lot of things are there. That is the hardware structure. I don't want to go inside that. Okay, so anyways, this is how the basic structure is. Now, ultimately what happens is this. Okay, ultimately what happens is, so this mobile or this base station will ultimately will push this data into an RF unit, and RF unit will generate an RF signal from the correct. So when it generates an RF signal, all these parameters comes into picture. So which parameters? What is the band you're using? How much bandwidth you're using? What is OFDMA? What is OFDMA? What is SCFDMA? What is modulation? What are the frames we have? What is the MIMO we have? All these are the basic challenges we have it in the base station.
So a quick question. What is the engineer god who works at a base station?
Okay. So any questions till here? Interesting, right? So now how these are working I'll discuss, but before that any questions?
Yes, I have a question. Can you hear me?
Faraz is talking, but
Faraz is talking.
Can you hear me now?
this is not audible for us. Yeah, could you type the message actually?
Could you type the message actually?
I have some audio issue. Please type the message.
I have some audio issues. Please type the message.
So,
It's speaker issue. Yeah. I'll try to resolve it. Maybe down the line.
I try to resolve it.
The engineer who works on the base station is called as a network engineer. Okay, the base station the engineer who works on the P is called as a network engineer. Or you can means actually there are a lot of engineers. Okay, you can say an RF engineer who works only on RF part. They are engineers who work on only KPI performance. Okay, so he's called as a KPI engineer. They are optimizers, okay, and they are designers who design the base stations, okay, while implementing. Yeah. A lot of engineers are there. That part I'll discuss. Okay. A lot of engineers. So, anyways, okay. So the division of the work is actually huge. Okay, so who does what work I'll discuss. Okay, there are a lot of engineers. So before that, if you understand these terminologies, then you will only come to know what exactly we have to do in the network. Okay, basically, frequency plays a very important role to communicate between the UE and the base station, right? So basically, the frequency of the signal. So basically, frequency plays a very, very important role between mobile to in-orbit. So frequency is playing a very, very important. So the question is, what do you mean by a frequency? Okay. So what is frequency? Okay. So there could be a lot of questions, but I can simply say is frequency is nothing but it's an electromagnetic signal which is invisible to your eyes. Okay. So light is visible, that is also electromagnetic signal. Okay, but there are some electromagnetic signals which are invisible to your eyes. Okay, so I can say any wave, any signal. Okay, so is actually electromagnetic signal, or it can be a sound signal, or it can be an electrical signal, isn't it? There are three ways to communicate. One is you should either communicate using sound, or you can communicate using electrical signals, or you can communicate using electromagnetic signals. So electrical signals generally use a LAN cable to communicate, right? So or an you can say even optical fiber is also using EM signals only, that I don't want to come. So LAN cables are using electrical signals. Sound signals, anyways, they don't reach a long distance, right? So it's useless. Sound signals you can only, if you shout from here, it reaches some little distance only. So they're mostly not used anywhere for communication. Okay, so only human being communicate with the sound signals. Okay, so we have only two forms, either electrical signal or electromagnetic signal. So now this electromagnetic signal communication happens in two modes. Okay, so one is using OFC, optical fiber cable. Okay, so in an OFC cable, optical fiber cable, you can push your electromagnetic signals. Okay, I'm again saying light is an electromagnetic signal. Okay, Like light, there are a lot of signals. Okay, radio waves are electromagnetic. Light is electromagnetic, and UV rays are electromagnetic. Okay, X-rays are electromagnetic. Okay, and gamma rays are electromagnetic. Okay, gamma rays are electromagnetic. Beta rays are electromagnetic. So there are so many electromagnetic signals. All are electromagnetic. All are electromagnetic. Out of this, only light is visible. Okay, remaining all are invisible. Okay. So why they are invisible? Because their frequencies are different. Only difference between this and this is radio signal and light signal's frequency is different and radio signal's frequency is different. So whatever it is. So this electromagnetic signal can be communicated or can be transferred using two ways. One is using fiber, that is optical fiber cable or fiber. Or second one is using wireless. Okay, using a wireless mode. So now, okay, so what do you prefer? I prefer both, isn't it? I prefer both because this electromagnetic signal is carrying actually a huge amount of data. It can carry a high amounts of data and it can go for a very far distances. For that reason I generally prefer EM signals. So basically, when you use a fiber means cable, you have to be again a fixed connectivity. You cannot move, right? So whenever you have a cable from your phone to your whatever the network, okay, so it will become a fixed network, right? So you cannot move. So this you cannot have. You can have between E node B to EPC. We will basically take this. But what you have to do if you want to move, you have to be a wireless, isn't it? If you want to a movable position, if you want to use a mobile, definitely you have to use a wireless. Okay, so that means in wireless we are using electromagnetic signal. So in electromagnetic signal, especially in wireless, okay, we have a lot of losses. Okay, so even though we could have used all these signals, but very least losses are present in low radio signals only. All the other signals undergo huge losses if you transfer. Okay, so interference is high in all other signals. For that reason, basically we go for radio signals. So now, in one single statement, what I can say is between base station to UE, the signal what we use is, okay, electromagnetic signal. Okay, it is in wireless mode. Okay, that too in electromagnetic signal, which signal we use using only mostly radio waves. Okay, so till 4G. Okay, so in 5G we are using, okay, so in 5G we are using microwaves also. In 5G we are using microwaves. So when you use microwaves, okay, the coverage will dip like nothing. It has to be very small coverage. So it will be, okay, the 5G base station HNB, okay, only has around 300 meters. That's it. It can only cover 300 meters. 3G's base station, 5G's base station. Whereas this 4G's base station, that is LTE's base station, has at least a coverage of around 3 kilometers. It can have high coverage. Okay, it even can cover more distance, but throughput dips. So generally we cover 1 to 3 kilometers. But whereas 5G base station, as they are using microwaves in 5G, so we are using it. So as of now, we can discuss this part. So any questions still here? 5G frequencies. Okay, so it is 50 gigahertz. Okay, so up to okay, the last frequency is from okay till 65 gigahertz. I'll discuss on 5G. Huh? I'll discuss. The last frequency of 5G is 65 gigahertz. So whatever it is. So now, okay, basically now what is happening is So in that case, they would have installed a Xeon base station before introducing 5G. Yes, yes, yes. So now all base stations has to change. Okay, their RF part, RF design, everything has to change because the frequencies between 4G and 5G are actually very different. Okay, so this was only to accommodate more speeds of data. You can pump around 20 Gbps of data in 5G. Okay, give me a minute. I'll continue. Okay, so this is how actually the things are working out. Now, not backhaul, I'm saying front RF part. RF part is microwave in 5G. So I'll tell you what is the reason behind it. Okay. So I'll compare a 3G, 4G and the 5G base station. Okay. So I'll have a comparison. So this is a 4G base station and this is a 5G base station. Yeah. I'll tell you. Okay, we are not much on that. Okay. So now, so basically now when I say when you're working on 2G, 3G, or 4G, okay, basically what they have is okay whether 2G, 3G, or 4G. Okay, so we are using which waves? We are using basically radio waves. So the range of radio waves is 100 megahertz to around 3000 megahertz. 100 megahertz to 3000 megahertz is the range of radio waves. Now, from this only all bands are being picked up. Bands are picked up means so we take band numbers means we select the ranges means between 100 to 3000 megahertz. What we try to do is maybe 900 to 890 to 960. We say some band number for this. This is one range of frequencies, megahertz. Okay, 19202 to 170. 170 is some more range of band. This is one more range. This is range number 1. This is range number 2. Okay, this way we have multiple ranges. Okay, so each range is called as one band. Okay, so for example, your full name is, okay, what is your full name? So for example, you have some full name. So Sai Venkata Prasad Rao. Okay, so every time will I call Sai Venkata Prasad Rao? No, right? So what I'll do, I'll say Rao. Hi Rao, how are you? When I say Rao, you will come to me. Okay, same way. So even though range is from 890 to 960, we never every time say 890 to 60. We give a number to it. Okay, I'll say this range I'm calling it as band. Band is nothing but exact definition of band is nothing but range of frequencies. Range of frequencies. Okay, it is nothing but it is a range of frequencies. So for this, presuming for this I'll give the number 1. For this for this range I'll give number 5. For one more range, okay, maybe 2400 to 2560, I'll give number 3, 2. So 1, 2, so presuming this is 3. So 1, 2, 3. So now whenever I say number 1, means whenever I say Rao, you should know he is Sai Venkata Prasad Rao, isn't it? So whenever I say 1, you should understand it is 1922, 2170. Whenever I say 2, you should know that it is 2400 to 2560. So this is a number game. Okay, so that means a shortcut name. So a shortcut name. Okay, so range of a number given to range of frequencies. Band is nothing but more exact, precise meaning is number given to range of frequencies. Okay, so now in that too that okay that is we are picking between what 300 to 3000 megahertz only, because that is the feasible range in which we do not have losses, and this frequency is called as radio frequency, which is used for telecommunication, and this frequency is called as radio frequency. Basically we are using this frequency for telecommunication, that is between 100 megahertz to 3000 megahertz. And what we are trying to do is we have a band is we have given some range for it. Okay, so now this way, okay, in this range of 100 to 3000 megahertz, we have bands from band number 1, band number 2, band number 3, band number 4, band number 5, band number 6, band number 7, band number 8, so on, band number 30, 31, 32, so on, 40, 41, so on, okay, 45, 46, 47, so on, okay, 61, 62, so on, 67, till here we are. There's so many numbers given. So 1 means, whenever I say 1 means 1922 2170 is a total range of frequencies, megahertz. 2 means a different range. A 3 means different range. So till 47 is what we are using. So the remaining is we are using it, but they are means they are not being implemented till now. Implementation is still only 1 to 40. Okay, so this is what we have it. So now so this is one part of the discussion. The second part of the discussion, I'll just, for a small statement, I would like to compare between 4G and 5G. So when I take a 4G base station, so basically we have ranges in megahertz only, right? So now this base station at max uses 20 megahertz out of the given range. How much it uses? Maximum 20 megahertz. Okay, whereas 5G base station requires, okay, 5G base station requires around a frequency for one user only. I require around, okay, so 400 megahertz. For one user only I require how much? 400 megahertz. If I have 10 users, it will become 4000 megahertz, right? So much of frequency from where I will allocate him. At least till 20 I am adjusting. Means for 4G 20, 3G it is 5 megahertz, and 2G it is only zero point 0.2 megahertz. So this way anyways I was adjusting in between this range, right? Between 100 to 3000 megahertz I was anywhere adjusting it, that too very tightly. Okay, now I want to accommodate more, means I want to give more bandwidth. If I give more bandwidth, I'll get more speed. So from where I'll get it? So I do not add any option. Okay, even though I have more losses in microwave I have more losses. Still I have to go for microwave frequencies. Actually, microwave frequencies are huge losses. Still I have to go for microwave frequencies. Now I have extended my range from 3000 megahertz to microwave starts from 3000 megahertz to 66 gigahertz. How much? 3000 megahertz to 66 gigahertz is what I'm using it in which technology? So for getting more bandwidth, so I have now extended huge numbers. So for that reason, we are going for microwave frequencies. So now the problem is we have more losses. For that reason, we cannot cover high range in the 5G base stations. The 5G base station coverage is very, very small. Okay. Any questions? There's some audio problem. Okay, I'll try to troubleshoot it. Maybe in the last class also we had it. So any questions you can type down.
Why are we doing so much bandwidth for a single user?
Not single user. This has to be used. This can be used by multiple users in this range.
It will be dynamic resource allocation.
Yeah, obviously it is dynamic, but that is a huge range. Dynamic, but there is a huge range. We again have bands. We again have access to bands.
Can you hear me?
Anyways, we will not go for 5G as of now. Okay, let us understand 4G very well as of now. Then I understand 4G very well, because that's the reason I do not want to elaborate more on 5G part. Okay, again this. So when you listen 5G, again you will start saying that you only want to listen 5G only. You don't want to listen 4G back. Okay. So for that reason, let's first complete 4G. Then I'll have high and hot discussion on 5G part at the end of our discussions. Okay. So then you can have a very neck-to-neck comparison between 4G and 5G, so that you'll get a very clear picture why we are using these kind of things in 4G and 5G. So anyways, now what is happening is, okay, okay. So now what is happening is, we have 4G. In 4G, what we have is, okay. So how many countries are there in the world? So anybody good at GK? So I guess around 210. I'm guessing there are around 210 countries in the world. So every country has a different operator, right? Obviously, every country should have a different operator, and presuming every country has a wireless network today's date, right? Every country has it. So now, if we divide this in the regions, okay, we say some Asia region, okay, East Asia region, South Asia region, isn't it? and West Asia region, and Australia region is called as Pacific region, and we have US zone, we have Canada, okay, and we have South America, and this is North America, and we have Africa. So why I'm showing the world map to you? Why I'm showing the world map is, okay, because every country, okay, operators or every country's government, okay, has planned to take different range of frequencies. Okay, so like for example, in India, names taken are Sai Shankar Venkata Prasad. Okay, now can you get this name anywhere in Africa? Any child born, brought up, so given this name Sai Venkata, Sai Prasad? No, right? So they are different, right? Their names are different. Okay. So in the same way, US names are different, Europe names are different. So in the same way, what these guys are doing, everybody has their own taste. Okay. So for that reason, what they try to do is everybody, okay, even though 3GPP has defined how many ranges? Okay, how many ranges? 1 to 47 bands. How many ranges? There are 1 to in fact 67 bands, but as of now you can take it as 1 to 47. So we are how many bands? 1 to 47 bands are there as per the 3GPP. So India has, okay, for example, I take India, Reliance Jio has taken band number 7, B7. Which band? India's Reliance has selected which band? Band number 7. Means that is a separate set of range of frequencies. Whereas Japan, we have an operator that is called as Docomo. Okay. So in Japan, we have an operator that is called as Docomo. Docomo has selected a band 41. Which band? Band 41. So in US, we have AT&T. Okay, AT&T has selected, I'm not sure, it has selected band 11 or something like that in FDD and TDD. That I'll discuss on that. So that means what I want to say is everybody want to be a variable part. So what they did is they selected a different range of bands what you have. Okay, so and the other important thing is, very important thing is, okay, if you buy a mobile phone in US market which is not supporting Indian band, you bring here and you try to connect with a Geo network or somebody other's network, it will not connect. So that's the reason you should be very careful whenever you're buying a mobile phone, because all mobiles does not support all bands. Getting my point? All mobiles does not support all bands. So that there is something called as UE capability. Okay, there is a message what UE sends to the network, I'm capable of these bands. Okay, so if UE is not capable of some specific bands, okay, so you cannot talk to the network. So it's a very big story. I do not want to go in deep into it. So means now I'm cutting back to our story what we require. Okay, so the requirement what we have is we should understand that we have bands. Okay, so that is what I told you at the starting. So what I told you is, okay, we have something called as bands. So what is bands? Okay, an index number given to range of frequencies. An index number given to range of frequencies, the index number starting from 1 to 47. Okay, so now, okay, in this index numbers, I'll show you. Okay, I'll show you the picture, then you'll get a very clear thing. Okay, now in this given index numbers from 1 to 47, okay, these are like your roll numbers. Roll number 1, yes, some name. Roll number 2, some name. So these are like your roll numbers. Bands are like roll numbers and the ranges of the frequency. So now when I take band number 1, example band number 1. So what is its range? 1922 2170 megahertz is range. Is the range of frequencies. So now this is your base station. This is my mobile. So mobile only talks one way or two way? Mobile talks two ways or one way? Two ways. Previous mobiles used to talk one way. Nowadays mobiles are talking two way. So whenever there is a two-way communication, it is called as what? Duplex communication. It's two-way communication. Okay. So whenever you're talking two ways, so upwards is called as uplink, downwards is called as downlink. So we have uplink and we have downlink. So whenever downlink means the base station is sending something and you is sending something in the uplink. So now when mobile is communicating something in the uplink, when the mobile is communicating something in the uplink, okay, so this frequency should be different and this frequency range should be different. Otherwise there will be interference. So what I'm dividing is I have to divide among this band 1, B1 only. So in B1 what I'm doing is I'm dividing 1922, okay, 1922, 1980 for uplink, 1922, 1980 as uplink, 21102, 2170 as downlink. Getting my point? I'm dividing this range into two parts. Okay, so initially what I divided from which part? 100 megahertz to 3000 megahertz. What's my range of RF radio signals? Out of that I picked this range. How much? 1922 to 2170 is one part. Now in this part what I am doing is I am again further dividing into 1922, 1980 and 2110 to 2170 megahertz. This is uplink and this is downlink. So there is some gap, right? Okay, again I am writing 1922, 1980. Yes, they should be equal. Okay, I'll tell you how it works out. Okay, I'll tell you. Okay, this is the uplink and this uplink, and 21102, 2170 is downlink. Okay, 1920 to 1980 is uplink and 21102, 2170 is downlink. So now what happened to the middle part? Who ate away the middle part, isn't it? So where is between 1980 to 2110? Who ate away that middle part? That middle part is called as duplex distance. What is called as duplex distance. So it works in this fashion. Okay, it works in this fashion. So that means if a mobile user, this is your base station, this is your mobile. So if I'm using in uplink 1920 megahertz in uplink, in downlink what I use 2110 megahertz in downlink. Okay, so if I'm using 1921 in uplink, I'll use 2111. Means I have to maintain a gap of how much? 190 megahertz. How much? I have to maintain a gap of how much? 190 megahertz. Otherwise there will be interference. if you don't maintain a gap. Okay, so for example, what I can say is, uh, I'm throwing two balls together. I'm throwing two balls together. Means we are playing a catching game. Means I throw a ball to you and you throw a ball to me. Okay, so both are green. Both are green balls. What will happen? Okay, you want to know which is your ball. So what will happen? So if both are green, both will mix, right? So which ball is yours, you will not know. So what I have to do? I have to change the color. So if I change one to light green and green, still it is very difficult. So what I have to do? I should have a high difference, right? So I'll make it as a brown color, one I make it as a green color. So then I will avoid interference. Okay, in the same way, whenever I use a frequency of 1920 in the uplink and whenever I use a frequency in the downlink as 2110, so I maintain some distance, then there will be no interference. For that reason, we are getting this gap. If I use 1980 plus 190, how much it will be? 1980 plus 190, how much? 2170. So there is no place to accommodate 1981. If I accommodate 1981, it will cross out of my limits, isn't it? So duplex distance will be out of it. So anyways, the story is again a long story. I do not go into deep part of it. So now what I can say is, okay, this is very important basics, guys. Okay, why it is important is, so this is where you actually work when you work in any protocol, anything, RF, anything, anywhere. So now what I want to say is, so now we have total range of RF range. From RF range we picked bands. From bands we picked one band, isn't it? From this one band we picked uplink range different, downlink range different. UL means uplink, DL means downlink. So this has a range, different range. This has a different range of frequencies, isn't it? So this is how it is working out. Getting the point?
To remove interference.
Yes. To remove interference, we are using different frequencies and we have to maintain some gap. That distance is called as duplex distance. Okay, so now I'll come to more technical part. So frequency is more commonly called as EAR, FDD, 4G. So in LT, frequency is also called as what? EARFCL. E stands for EU-TRAN. Okay, so EU-TRAN stands for enhanced. Means we have enhanced from UMTS. UMTS, terrestrial, radio access network. So this is actually the name of 3G. Okay. So UMTS stands for. Okay, again you don't have to buy at all these things stories, guys. Okay. So this is universal mobile telecommunication system. Okay, we have UMTS, okay, EU-TRAN and EARFCN. Okay, so in EARFCN, E stands for EUTRAN. EUTRAN stands for Enhanced UMTS Terrestrial Radio Access Network. So again, UMTS stands for Universal Mobile Telecommunication System. So now the remaining part, ARFCN stands for Absolute Radio Frequency Number. Absolute radio frequency number. So you don't have to remember enhanced UMTS terrestrial radio access network. Again, UMTS stands for Universal Mobile. No need all those stories. Only what you have to remember is ERFCN, where E stands for EUTRAN. That's it. Okay, so you have to remember EUTRAN. So E stands for EUTRAN, absolute radio frequency channel number. So this is, okay, why I told you all this is an other name for frequency. This is another name for frequency. So that means what I can say is, generally when we talk in terms of LTE terminology, this is your base station, this is your UE. Okay, UL frequency is called as UL EARFCN. DL frequency is called as DL EARFCN. This is how it works out. Now I'm coming back to the bands part. Okay, so I'll just Google it. You have a look on this part, and you can also have a Google on this. I'll just end the class within 1 or 2 minutes, but just before that, I'll just Google and I'll show you the bands. So you can type google.com, and just after the class, you have a look on this. Okay, so LTE bands wiki. LTE bands Wikipedia. So I'll just go down. So these are the bands list that I have. So I open this. So band range is starting from, okay, if you see here, what all the things? Band, duplex mode, I'll discuss on this, FDD or TDD. Frequency range, in which region it is used, America, Australia, whatever it is. Okay, this I'll tell. What is its uplink frequency, what is its downlink frequency, what is its duplex distance, and what all its bandwidths. I'll discuss on all these things. So now, yes, UL has a separate channel number, DL has a separate channel number. So now if I go down, so this way how many bands we have? Okay, now it is extended to 85. When I saw it was 67 only. Now it is 85. You don't have to worry about all those. Okay, you can say maximum you're using till 47. Okay. So now I'll go to the band number 1, what we are discussing. So what is the band number 1? Band number 1 is frequency is 2100. So its full name is 1920 to 1980 is uplink. This is what we have discussed. And 2110 to 2170 is downlink. Okay. And what is its duplex distance? 190 megahertz. In the same way, band 2 has some range, band 3 has some range, band 4 has some range. You don't have to remember all these ranges, but at least one range is what you have to remember. That range, which operator you are working on the project, that is what you have to remember it. So instead of frequencies, what is this called as? EARFCN in uplink and EARFCN in downlink. So more on this part of the discussion will continue tomorrow. So I'm ending for today. Thank you. Have other class waiting. People are waiting for that.